Hi everyone. So this is the last lecture for the mobile computing class. So today we're going to talk about multimodal interaction. We have briefly talked about this topic before, and now we will expand a little bit about multimodal interaction in the sense that you'll see how to actually implement some of these and see some examples of this. This class was taught on the week 7, so that's the last lecture of the third period of the class, and you right now should be wrapping up your homework 5 so that you complete the first part of the course, and then we will move to the independent project. So some of you are working in teams, some of you are working alone. So if you haven't done so, please let us know in Moodle. In the Q&A section, there's a topic where you say whether or not you're going to do it individually or you're going to do it with a team. So please do that before this period here starts. Because the first milestone is already on the 16th of March. So please do this as soon as possible. If you don't say anything, we will assume that you're going to do the independent project. And so if we don't get these deliverables done by these dates, then we will assume that you quit the actual course. These milestones here, so they are relatively, you have relatively a month, almost 2 months to work on this project, and actually 2 months here. And these milestones are here just to make sure that you actually are proceeding with your course and you don't leave everything for the last minute. So the ideal use case here is that you have thought about how the application is going to look like and how it's going to how the user is going to interact with the application, and then you move to creating the actual interfaces using the Android Studio UI designer, so you can create those, and then you would take the screenshot of that interface, and then you would do the implementation side. So there's a month in here basically that you would spend implementing the functionality between the interface that you have designed before and the actual functionality of the application. And then the milestone, the last one, is to make a video of your actual application. So just see how the previous year's videos look like and do a promotion video of your app. The idea here is mostly to make it into like an advertisement for your actual application. The previous year's videos are shared, or there's a link for the playlist on YouTube, and it's on the first slides of the lectures. So moving on to the actual class today. So multimodal interaction involves the senses of the human, and so you have the visual, the auditory, the haptics, and the touch. And so this is more on the multimodal interaction from a mobile standpoint. So if you think about the visual side of things, this is the actual graphics interface of the application. If you think about auditory, this is the sound that your phone can make. Haptic is probably going to be taking the shape of vibration or gesture recognition that you can do. And then touch, normally it's the press and the swipes and the long presses and pinching. So multimodality, when you think about multimodality, you would combine a set of these two together in order to enable the user interaction with your application or system. So let's start going through some of these. So for example, one case that you could think about is where you have text to speech. So we are using the auditory multimodality modality here. So the text is sent to a speech synthesizer, and then the speech synthesizer will try to mimic the human voice. An example of that is, for example, Stephen Hawking. So there's a small video here of how this actually worked for him.
I communicate with the computer system in a box in the back of my wheelchair. This system was put together for me by David Mason of Cambridge Adaptive Communications. On the computer, I run a program called Equalizer. A cursor moves across the upper part of the screen. I can stop it by pressing a switch in my hand. In this way, I can select words which are printed on the lower part of the screen. When I have built up a sentence, I can send it to a speech synthesizer. I use a separate synthesizer made by Speech Plus, a division of Sendigram Communications Corporation. I can save what I write on disk. I write papers using a formatting program called TeX. I can write equations in words, and the program translates them into symbols and prints them out on paper in the appropriate type. I can also give lectures. I write the lecture beforehand and save it on disk. I can then send it to the speech synthesizer, a sentence at a time. It works quite well, and I can try out the lecture and polish it before I give it. In a similar way, I can make a CD-ROM. But to do this, I need a little help from my friends.
Yeah. So, in a nutshell, the computer there converts texts into robotics kind of voice synthesizing. So, text-to-speech is actually available on most Android smartphones because it's part of the accessibility services of the actual operating system. You can also, so that's the class that is available, library that is available on Android. And so the way it works is that you would create an instance of that class, and then you can initialize it inside your application. So this is the activity that you have, and this is where we initialize it. We can specify how fast the speech is going to be, and also how high the pitch is going to be. And this is how you would actually ask it to speak. So you would replace this with a string. In this case, in this example, I'm showing it, I'm reading it from text input. So when you run this class for the first time, you need to implement this interface on initialization listener. And that's this function here that this will require you to implement inside your activity. And so what you need to do is check the status of that. So if the text-to-speech is available on the phone, then everything's okay. Otherwise, you can actually ask the device to install the missing text-to-speech library. Like I said, since Android 4, this text-to-speech comes as part of the Android Studio, the Android OS, and so many times this is not needed, but it can happen that some manufacturer did not include the text-to-speech. So it's always a good to check whether or not the actual text-to-speech library is installed on the phone. Don't forget to turn it off whenever your application, your activity is destroyed. Because otherwise this is just going to keep running on the background and it will drain your battery. So talking about the speech rate and the pitch, so if you 1.0 is the normal, what would be considered normal. So if we increase the speech rate, it will make the sound way faster, and then if you have less than 1, it means that it will be slower, and then if you have the pitch higher, it makes it actually sound like you have helium, like as if it was helium. So let me show you how that looks like. So I have here a demo. So this is my phone here. So I have installed this. So this is the text-to-speech part. So if I open that.
Hi, hello there.
So I can say here, hello, how are you? Okay. And if I do it so that the speech rate is lower and also the pitch is lower, this is how it sounds.
Hello, how are you?
But if I make the speech faster and also the pitch faster, this is how it sounds.
Hello, how are you?
And this is the normal speech.
Hello, how are you?
So it sounds quite natural and not so robotic like you saw here.
Hello, how are you?
So Stephen Hawking's voice was set more or less like this. The text-to-speech library that is currently on Android is much more natural sounding than, for example, the software that Stephen Hawking was using. So if we think about speech synthesis, how does it work? So Google has a very nice video on how this process actually works. So I'm gonna share with you this video so you can also see this video.
One more time.
One more time.
Hi, I'm Nat.
And I'm Lo, and this is Nat and Lo's 20% project, where we go around Google learning about all the stuff we're curious about,
And today we're going behind the scenes of the new Google Voice.
which is not Lo.
So, a few years ago, Google added voice search as one of the ways you can search for something. And if you've ever tried it out,
Okay, Google. How tall is an elephant?
African elephant has a height of 11 feet.
You've probably noticed that computer voice that talks back to you. We got word that there was a team at Google creating a new voice for the Google app, and we got really excited to learn how do you actually create a computer voice.
So we got into the recording studio and met James, the voice coach, and Erica, a linguist, and the new voice talent.
So this is silly.
Yeah, this is totally silly. So you guys are on camera, and I don't have to be seen.
We're invading your home.
I love it.
When was the first text-to-speech voice made?
the main thing that we think of as speech synthesis mostly started in the 80s.
Back then, they were using an approach that was completely computer-generated, but now how text-to-speech voices are typically made is that a person records thousands and thousands of sentences, and then out of all those sentences and all the sounds that they contain, magically a voice is made.
When we do speech synthesis, what we're doing is stringing together units of sound to combine them in new ways to make new speech. Units of sound can be phonemes, the smallest unit of sound that distinguishes meaning. So from stack to slack, suddenly it's a completely different word. You've changed the meaning just by swapping one sound for another. Phones.
I can think of 8 kinds of tea, 8 flavors of tea in English. Those are phones. Top, top. So you see the paper moved when I said the T, but what happens if I put an S before top? Stop, stop.
And iPhones.
It's essentially the transition from one sound to another.
What is the sound of an S before W? What's the sound of an S before an I? What's the sound of a T at the beginning of a word?
Erica and James told us that the bulk of these recordings are for getting good diphthong coverage, because these transitionary sounds are really fundamental to how speech works.
So once you're done and happy with what you have, then what happens?
Then the recordings are kind of stored in a database.
Any content that hasn't been pre-recorded would have to be stitched together.
It's essentially a search problem. It'll be like, okay, I need to put this sound with this sound with this sound. Let me look through the recordings, and then stitches them all together into smooth speech.
Synthesized speech can be great at taking text and turning it into speech on the fly, but it can kind of end up sounding a bit robotic.
So probably one of the biggest reasons that the team is creating a new voice is to do more detailed recordings that will add more nuance to how the voice sounds.
A typical grilled cheese sandwich made with 2 slices of white bread, margarine, and 26 grams of processed American or cheddar cheese contains 291 calories.
I think my favorite part is sandwich.
Really?
Yeah.
The way I said
say
the word
sandwich,
sandwich?
say sandwich again.
A typical grilled cheese sandwich made with...
Sandwich, yeah, sandwich. I love that.
So a big problem in speech synthesis right now is prosody and intonation.
Which means the way the speech sounds. It's rise and fall. It's rhythm and melody.
Let me give you an example from just regular language. What's your name?
Lorraine.
What's your name?
Lorraine.
So the first time my melody went down, when I was a request for repetition or for clarification, my voice went up. We've never been able to do this before.
To try to add all these different layers of melody and stress and intonation and whatever other nuances that we have when we speak, the team has been doing these recordings that are almost mini plays where James, the voice coach, acts as a user. And then the voice talent can respond back in different ways depending on different situations.
Okay, Google, I need to send a text.
Who do you want to text?
Madison?
Madison, sure. Mobile or work?
Mobile.
What's the message?
So the user just dictated the message.
Got it. Here's your message. Do you want to send it?
Actually, no.
Do you want to change the message? Do you want to change the message?
That was good. That was lower. That was the right pitch. Yeah.
So the new voice will actually be a combination of these whole chunk recordings along with splicing together units of speech.
We wanted to understand how it feels to actually be the person who's expected to be the new computer voice. So we asked the voice talent if she had any tips for us.
It takes a lot more energy and air than you think to keep the voice going and to keep it energetic and clear.
So I have to learn in the next few minutes to speak from my diaphragm.
To speak from your diaphragm. It takes a lot of energy.
Okay, Google. I need to put something on my calendar.
When's the event?
Tuesday.
At what time?
It sounds a little bit tense and you're starting a little bit high. Think of it as a smooth figure skater on ice.
At what time?
Okay, a little lower.
At what time?
Sorry, what's the day and time?
Now let's try one like this. Sorry, what's the day and time?
Sorry, what's the day and time?
Ooh, that was really good.
Happy with it, guys?
I liked it. It's a wrap.
That's a wrap.
That's a wrap.
All right. So you can see that it takes a lot of training for speech synthesis to work and a lot of data, and it's really search challenge in terms of the database and getting these things. So what happens if you combine gestures and text and speech? You get sign language. So here's an example of how you could combine gesture recognition using a leap motion as well as the text-to-speech capabilities of computers nowadays.
Next. Milk. Okay. Peace. Sorry. You. Player. Next. Angry. Glasses.
Scissors. Book.
Turn around.
Enough. Go. Opposite.
Yeah, so if we think about this, how about the opposite? So if we want to convert speech to text, so instead of text to speech, we want the opposite. So that's speech recognition. So we convert sound waves, which is the speech, into text form, so parsable commands, if you think about it. So the speech recognition actually has increased significantly in recent years, simply because the machine learning and deep learning algorithms have increased the understanding and the accuracy of these algorithms. So previously, if I would say to my computer, to my Google Assistant, do I have anything today? My assistant would actually say, sorry, I don't understand. And the reason for that is because I don't say specifically what is it that I want. So do I have something today or anything today? And so the speech recognition doesn't understand the context in which I want to know. So do I have anything today where? In my calendar, in my email? And so it really wasn't clear. But it has learned as I've been using it, it has learned what I mean with this. And so nowadays, if I ask this question to my Google Assistant, I actually hear what I have on my calendar, for example. So to do speech recognition on Android is relatively simple. So there's an actual intent that you can use that triggers the recognition of speech, and it is available in most devices because it's part of the Google services actually. And so if we, for example, in here, in this example here, I have a button where I press it and then I literally create an intent, which is this recognizer intent action to recognize speech. I specify what is the model that I want to use to understand what I'm saying. So you have two models. One of them is free form, so you can say whatever you want, and there's one that is for web searches, so you can specify like a URL. You can also specify the language in which the input is going to be. So in my case I had here US, but you can change it to different ones. You can also specify how many results you want back. So if you just want the most accurate one, you just put 1 in there, but you can actually put 2, 3, 10, and it will give you a list of potential matches with also the accuracies. This prompt here is what appears on the screen to let the user know that the device is ready to listen to his input. And this activity that recognizes speech will be triggered, and then the result of that is a callback that will come for your application activity. So this on activity result, you will get the request code, so that's the same ID here, and I just added as 1, 2, 3, 4, 5, but you can be any number. And so if this is a callback that comes with that result ID, and if the result is okay, so that means that the user has interacted successfully with this intent, then you get the data as a string, an array of strings with the results, and then using so in this array, because I only specified one result, I can just go and get the item in position 0, which is the only one. I could also use here dot first, that also would work because it's an array. Yeah, so this is how it looks like. So let me show you how the speech recognition actually does. I already showed you the text-to-speech, so let me just show you how the speech recognition works. So if I open here the speech recognition, so that's this one here. Hello there. So as you can see, it recognized what I said, and I can say anything I want. Looks like it's gonna rain today. So you can see it's very accurate, and it works offline and also very fast. So that's the demo there. So let's move on. So let's talk about cameras. So the vision based. So if you're using smartphone cameras, it's actually going to depend a lot on the phone you have, because you will have more or less functionalities available to you depending on the device. This is because simply the manufacturers have different hardware drivers, and they have different manufacturers and sensors built in onto your phone. And so depending on what's available and is possible to do with your hardware, you will get access to different things. It also depends on the OS. So the version of the OS also affects what camera API you have available, and if you go online to search on how to focus a camera or things like that, it might happen that it actually doesn't work because simply your phone does not support that. Here's on this webpage from Google, there's a tutorial on how to acquire a picture and how do you save a picture into your phone with code. But here's an overview of what you can do. So you can actually reuse your phone's camera app to take a picture if you have building an application. So you will have to add to your manifest that your phone application will require access to the camera hardware. And so once you do that, you don't actually need to request the permissions to access the camera, because the actual app that will use the camera is going to be your phone's camera app. And so in here, all we're going to do is we're going to trigger an intent, which is this media store action image capture. And we are going to check which application do you have installed in your phone that is able to capture an image. And then with that, we would start this application for a result, which will be called back with this result camera photo, which is a variable I just defined here with as 1, 2, 3, 4. And then on the activity result, and if the code is that code that we had and the result is okay, then we can retrieve the data, which is the actual picture, as a bitmap, and we can save it to a file or set it into an image view. So in my example here, in my demo, I actually have an image view that I then set the image to the camera. So let me just show you how that looks like. So if I open back here, so this is reusing the camera app. So I have a camera app, which is this one here, and if I open that up, you'll see here that the interface looks like this. It has multiple options on the bottom, and allows me to flip between the camera and allows me to take a picture. So if I go back to the actual application for the demo, so if I'm reusing my own the camera that I have, okay. So if I open the reuse here, you'll see that it actually opens the actual camera app that I had, and I can take, for example, a picture, and then I can just save that, and that has been added to the interface of my application in this image view that I just specified. So what if I want to make my own camera app? Before I go there, so if you saw the picture here, if you don't rotate the image by 90 degrees left, it will, because by default the camera app assumes that you're holding your phone in a landscape mode, and so we need to rotate 90 degrees so that the picture is actually saved as portrait instead of a landscape. And this is simply because I took the picture as a selfie. So if I want to make my own camera app, Google has created a library that kind of makes it easier for you to create and have access to the camera without having to deal with what is possible and what is not possible on your phone. And so there's a link down there here that shows you how to get started with Camera X. And in a nutshell, so the Camera X introduces use cases of how people use or need to use the camera API. So it allows you to just think about what you need to get accomplished instead of thinking about how to deal with different device-specific challenges. So one of the three cases that they cover is getting a preview of the camera, do maybe some image analysis, connect to the camera feed and be able to do processing of the actual camera feed. So in the demo that I have, I'm doing it both with OpenCV as well as MLKit. So MLKit is a machine learning kit that allows you to process the data in real time and do some interesting things with the camera. Or you can just literally take a picture. So these use cases work across all devices running Android 5.0, which is API level 21, which is the minimum level API that the Google Play services actually support. And that actually runs in 97% of the devices nowadays on the Play Store. So let's see that if I wanted to create my own UI to take a picture, so how would that look like? So this is my own UI here. So if I open that up, this is a camera app that I made, and you can see here I have here two buttons on the interface. So I have to enable and disable the flash, so I can enable or turn off the flash. You can see the brightness of that in here on my camera. You can also take a picture. So for example, if I press it there, it will take a picture and it will save the picture on my phone. And I can also make the whole thing black and white. So for example, if I press there the filter button that I made, it will actually process the feed and make it black and white. And you can see here now everything's black and white. So I have a red bottle here, and it's actually black and white in there. Okay, so if I wanted to see the picture I just took, I can go to my files, and I can see here in the internal storage of my phone, I have here the application demo. So it's called example here. And this is the picture I just took, and you can see the picture is actually high resolution also. Yeah, and so that's how you could make your own camera app using the Camera X. So I will show you the source code of this right now. So let me just open up Android Studio here, so you can see here. So my own camera. So the first thing I'm doing is checking for permissions for the application, and if there's no permissions for the camera, I request the permissions, in this case for the camera as well as the storage, so otherwise I wouldn't be able to take the picture and save it locally on my phone. And like I said, the whole example, it's based on use cases. So first I start by creating a preview of the camera, and I can specify where is the preview going to be. I will add the image capture use case. So what happens when I press the button to take a picture? In my case, I'm saving the picture into a file, into the directory of pictures, and I'm saving the file name as own camera and then the timestamp. And then when I press the button, all I'm doing is I'm using the use case to do the image capture, and I take the picture, and the picture will be saved on the file that I just defined before. And once this picture is saved, I'm just using a snack bar to show that, okay, the photo is saved, and if there was a problem, it would actually say that it failed to save the picture. Are we running out of space, for example? So for the OpenCV, I created an image analysis use case, and then when I press the button to filter, I initialize OpenCV, and then I use a image process to convert RGB to grayscale. And so when the analysis occurs, so I set here the analyzer. So for every frame that I get the image that has been previewed, I get the bitmap of that, and then I create a matrix that converts all the RGB colors to the color scheme of gray, and then I just put that back into the bitmap, and all of that happens in real time. And so, for example, to enable and disable the flash, all I'm going to do here is for the preview, I just enable the torch, and that changes how the preview. So the preview is when you get what you're seeing on the camera, so you can enable and disable the torch in there. Okay. And so the camera X actually handles enabling and disabling the camera sensor. So when we bind it to the life cycle of the actual activity, all of that is taken care of for you. So here you have all the use cases I defined. So I have the life cycle owner is this activity, and then in those use cases I have the preview, I have the camera to take the picture, and also the analysis. Here's a function that I just made to check whether or not the camera has been granted permission. So I just do a check whether or not that permission exists, and it has been granted. And here I have a check here whether or not if the permissions have been denied, we show a toast saying that we need to have these permissions to run this application, and we finish the activity. Otherwise we are ready to go and we start the camera. So you can see it didn't take that much code to initialize the camera, set a preview, do an action of what happens when you press the button to take a photo, and also do a real-time black and white preview of the actual camera. This could be black and white, but it can also be other things. So you would need to go through OpenCV documentation to change this to something else if you want to, and then you can do a more fancy camera application. Yeah, so let's go back to the slides. So that was the code for creating your own UI and also reusing the camera app. So let's talk about Google MLKit. So MLKit is another toolkit from Google that allows you to do to leverage machine vision algorithms in an easy API, and it actually makes a lot of the work that the folks at Google and also CMVS do on their research accessible to everyone. So here's a few examples that I have prepared for this class. So we have face detection, where it can detect your eyes, your smile, ears, etc. There's barcode detection, so you can actually detect and read barcodes, and also read text. So detect the text doing optical character recognition. So this is implemented on this project which I shared on GitHub. I also have a demo for that. So let me just show you all of these things working for you. So let's do first so this is the vision part here. Let's do first here.
Initializing supercomputer. Done.
Okay, let's do first the face detection, okay? Alright. So now it's right now trying to find a face.
I can see you.
So you can see me now, but if it doesn't see me,
where did you go?
And then if I come back,
I can see you.
And now I can smile. So I actually have programmed it to detect when I'm smiling.
What a beautiful smile.
Okay. So that's
what a beautiful smile. What a beautiful smile. What a beautiful smile.
So that's the demo for the vision there. But we can also do
initializing supercomputer. Done. What a beautiful smile. What a beautiful smile. What a beautiful smile.
So we can also do barcodes. So let's see here. So you can see here there's a barcode right there. So it's reading the barcode over there, 70 blah blah blah. So here's another one. 78158335277. So this is doing in real time. So as you can see, there's the frame rate is quite high. So that's why we're getting this barcode appearing and disappearing all the time. But it can also recognize text. So if I enable the text one, so you can see here it's actually recognizing what I'm pointing at. It's a bit tricky because here there's a lot of text in here. As you can see, it just keeps filling up in here. But it's literally reading what my camera is actually showing. Okay. So if I go back to the source code of this application, so that's the mobile vision here. So the code here, because I'm using text-to-speech combined with the ML kit, I have here a button to initialize the faces, a button to initialize the barcodes, and then a button to initialize the text recognition. So let's go through the faces. So the faces here, I create, like I said, first a preview of the front-facing camera, and then from there I do an image analysis algorithm from the front-facing camera. And for this analyzer, what I'm doing here is I'm using Firebase Vision Face Detection Builder, where I'm doing a fast face detection method, and then I'm getting all the landmarks. So the landmarks means the eyes, the smile, the ears, all of those. You can specify here if you just want something else. So you would you can specify. So you can just get the contours, so that gives you like the shape of your face and things like that, and all classifications. So I'm just going to use all landmarks here, and so the classification mode, it's all of them. The other thing that I'm doing here is that because of the camera being landscape or in portrait, using camera X, you can actually convert that automatically based on the actual acceleration of the camera or the device, or rotation of the device. So you can use this degrees to Firebase method to do this automatically. So when we analyze the image, we get the image, we make it rotate so that it's adjusted accordingly to the actual image taking, and then we load that image, and then we use the face detector, and for every detection, for every face, so if we have detected a face, we have the text-to-speech say, I can see you. If there's no faces, where did you go? And if there are faces and the person has a probability of being smiling with 90%, I guess I wasn't smiling hard enough in the beginning, but it just says here that, oh, what a beautiful smile, if the person is smiling. So similar to the barcode, so we create a preview, we set the image analysis in there, and then for the analysis itself, we just initialize the Firebase barcode detector, where we have support for all formats. And then for every image that we get, we apply the detector, which is this vision barcode detector, and for every successful barcode that we detect, so if we have found more than one, we actually show it in the snack bar. Remember that this is happening in real time, so depending on the frame rate that you have on your camera feed, you might want to change this code a little bit so that this would happen with a picture that you just took, for example, instead of doing it live like I did on this example here. And so this is also what happens when you do optical character recognition. So the OCR has been engaged. So the same way, we create a preview. In this case, I'm doing a back camera preview, and that's the lens facing backwards. And then we're going to do the analysis of that. So the preview is here, is also facing the backward. So we again have the rotation of the camera, and we are using this on-device text recognizer. There's also a cloud-based version of this, but that requires you to have a paying Firebase account. With this one, we don't need to, and for what we are doing here, actually we don't need a more fancy. So the on-device text recognizer can detect normal Latin-based characters, but it will not work with Chinese or Korean or any or Arabic. And so if you do the cloud-based, it actually recognizes those too. So if we have a text recognition in there, a text, and if the text is more than, there's some text in there, I'm just setting a preview and the text that has been recognized into that. If there's no text detected, it goes invisible in there. Yeah, so that's an overview of the text and how you can use Camera X to do fancier things with your phone. And so the code that you saw there is here, so you can just check out the project into your Android Studio and you can run this on your own phone and learn with that too. So there's another library that I didn't talk or show here in the examples, which is, for example, TensorFlow. So TensorFlow has been quite successful to do object recognition, and it's also available here on this link here down here below. So if you go there, you can actually run the demo that is running in here. So here you have a demo of that. So what you should notice here is that TensorFlow, the object recognition, only gives you a classification if the accuracy is more than 50, so at least 60 in there. You can see here the apple, it actually in the beginning thought it was something else. This is undecided whether or not it's a cup or a bottle, and so it's not 100%, but it actually works quite well. So there's the mouse right there, the scissors and the knife, teddy bear, and it thinks it's a bowl, but then it's a book, laptop, so that's quite easy. He actually goes, then thinks it's a TV, so it's not 100%, but it's getting much better over time, and so that actually recognizes that's a car, and there are some images in there of people outside. There's a person in another car. So of course it has some trouble to recognize things in motion sometimes, and of course it also depends on how focused the camera is. Yeah, so that's an overview of how you could also think about using TensorFlow if you want to do object recognition. So if you combine these modalities together, you could think about semi-autonomous drone control, for example. Here's a demo of that done by a lab. So here they're using speech to turn on the engine. So he can use a leap motion to control the drone. So he can also do person detection. So it's tracking the position of the body using vision algorithms. So in here it's also using almost like barcode recognition. It's called a marker. depending on what the drone sees, it will do an action. So you can also think about combining modalities in order to interact with virtual reality. So in this example here, we have gestures coming from the remote and also voice commands coming from the user, and that affects what happens on the virtual world. So here's an example of that.
Create a planet. Paint it red. Move it there. Create a sun. Make it bigger. Move it there. Rotate that planet around that sun. Move that sun there. Exterminate it.
So you can see you can actually combine these two in order to create a not so dependent on buttons interface between the user and virtual reality. So thinking about in the future, if you have seen the movie Her, I won't play the trailer here, so you can find this. So the movie Her shows a vision of the future where humans and computers have semi-autonomous relationships. So the computer, as your assistant, can actually do things for you proactively, and you as a user, you can interact with the computer using natural language, so you can talk to it and is able to think for you and make decisions for you. And this is a take, basically a Hollywood take, I guess, on how computers could evolve in the future, where multimodality interaction has a very strong prevalence. So in this case here, the interaction between the user and the computer happens through the camera that he has here on his pocket, as well as this ear speaker, so he can actually listen and talk with the computer, and the computer runs as an OS on his on all of his devices, basically. So that's it for this class. And so I hope you guys enjoyed the lectures this year, and I'm excited to see what you guys are going to build for your projects. So until, and we'll keep an eye on your progress on the project, and we'll give you feedback as you proceed with your project. Thanks guys, and I'll see you on the next one.